Hey guys, this is day 3 of volume. In this video, we're going to be finding the volume of a tank when some sort of object is inside and displacing some of the liquid. So let's get right into it. At the top of your notes, fill in the length, area, and volume measurements and formulas, please. All right, the first problem is a toyo. This is a review from yesterday, so go ahead and pause the video and give this a try on your own, and then come back and check your work. Okay, so you should have hopefully filled in the volume formula at the top of your notes there, or at the top of the problem, and then filled in the variables. So we've got 10 times 15 times 20, and if we multiply that, we're going to get 3,000 centimeters cubed. But our question says, what could this tank hold in liters? So we want to convert that to liters. And so we're going to write our conversion formula. Remember, our centimeters cubed will cross out, and now we have 3,000 divided by 1,000, and that's going to equal 3 liters. Okay, our next problem says, find the volume of water a rectangular tank 10 centimeters by 15 centimeters by 20 centimeters could hold in liters when a metal cube of edge 5 centimeters is in the tank. So what I want you to think about is, how would you go about this problem? Go ahead and think about a strategy right now, and then let's talk about it. Okay, well, hopefully you could see that what we're going to need to do is we're going to need to find the volume of the tank first, and then we're going to need to subtract the volume of the cube. Since that cube is taking up space in the tank, that's all space that water would not be able to be. So we're going to find the volume of both, and then we're going to subtract. So let's find the volume of our tank first. We've got V and then subscript tank, and it's important that you use subscripts when you're writing your formulas so that you can keep your work straight. And we'll fill in our variables, 10 times 15 times 20, and you already know the answer because we just did it in the last problem. The volume of the tank is 3,000 centimeters cubed. Now let's find the volume of the cube. It's going to be 5 times 5 times 5. It says right here that the metal cube is edge 5 centimeters. And the volume of the cube is going to be 125 centimeters cubed. And we're keeping all of this in centimeters cubed while we find the final volume of the empty space in the tank, and then we'll convert it to liters. All right, so we've got volume of the tank, 3,000 centimeters cubed, minus the volume of the small cube, which is 125 centimeters cubed, and we're going to get 2,875 centimeters cubed, and that's going to be the volume of the water that fits inside the tank. Our question asks, what can it hold in liters? So we'll convert that to liters, and we get 2.875 liters. All right, make sure you have all those notes. Pause the video if you need to, and I'll go ahead and move on. Okay, so now we have a similar situation. We have a rectangular tank. It's partially filled with water, but there's a stone inside. Let's read through it. A rectangular tank, 35 centimeters long and 25 centimeters wide, contained some water and a stone. The height of the water level was 10 centimeters. When the stone was taken out, the water level dropped to 8 centimeters. Find the volume of the stone. Okay, so this is a little bit harder, isn't it? First of all, let's underline what we're trying to find. We want to find the volume of the stone. Okay, so let's just underline that. I'm going to put a question mark by that. Okay, so I hope that you remember from the very first science unit that we can find the volume of an irregularly shaped object by putting it in some water and figuring out how much the water displaces. So think back to when we put those bolts in the graduated cylinder and we watched the water level rise, and we concluded that the difference in height was the volume of the bolts in milliliters. So we're doing something similar here. So what we're going to do is we're going to take the difference in height. So we started with 10 centimeters, and when we took the stone out, the water level dropped to 8 centimeters. And we can take that difference in height and put it into our volume equation and find the volume of that stone. Okay, so let's do that. Volume equals length times width times height. So we're going to plug in our variables, 30 centimeters times 20 centimeters times 2 We get that 2 from right here. That's the difference in height of the water from when the stone was in the water and when the stone was taken out of the water. And we'll go ahead and we'll find that volume. It's 1,200 centimeters cubed. And we're going to, let's see. We're going to go ahead and we're going to convert that to liters. We could leave it in centimeters cubed. The question, it doesn't actually tell us to convert it to liters, but we'll go ahead and do it anyways. So we've got 1.2 liters is the volume of the stone. All right, here we have a rectangular tank, 30 centimeters by 10 centimeters by 20 centimeters. Now notice that we have exactly the same measurements as the last problem. They're just switched around. Now we have a 10 centimeter width and a 20 centimeter height. It contains a water to depth of 10 centimeters. How many metal cubes of edge 10 centimeters need to be placed in the water to raise the water level to the brim of the tank? Okay, let's think through this problem really quick. What we can do is we can find the volume of the tank, and then we can find the volume of the water, and we can find the volume of the cube. And we're going to need to figure out how much water we need to go to the top, right? So what volume of water do we need? And basically it just needs to double. So since the height is 20 centimeters and we have 10 centimeters filled with water, we're going to need double the amount of water to fill the tank. So that difference is how many cubes we're going to need. So we'll calculate the volume of the cubes and we'll divide the amount of volume that we need by the number of cubes. Or excuse me, by the volume of the cube to get the number of cubes that we need. Okay, so let's find the volume of the tank first. We'll plug in our variables here, 30 times 10 times 20, and we get 6,000 centimeters cubed. And let's find the volume of the water, 30 times 10 times 10, and we get 3,000 centimeters cubed. So we can see that we need to make up 3,000 centimeters cubed with the volume of these cubes. So now let's find the volume of the cube. It says up here, the cubes have metal edge the metal cubes have an edge of 10 centimeters. So let's fill in our variables down here. We've got the volume of the cube, 10 times 10 times 10. The volume of the cube is 1,000 centimeters cubed. So since we need 3,000 centimeters cubed, and each cube is 1,000 centimeters cubed, that means we need 3 of them. Okay. We have a rectangular tank measuring 50 centimeters by 40 by 40, and it is half filled with water. When 3 metal cubes of edge 10 centimeters are placed in the tank, the water level rises. Find the height of the new water level. I'm just thinking through this problem, and I'm noticing that I already know the volume of those 3 cubes, right, because we just figured that out in the last problem. If they're 10 centimeters each for each edge, that means they're going to be 10 times 10 times 10, which will be 1,000 centimeters cubed each. There are 3 of them, so that means I have 3,000 centimeters cubed in there with the cubes. Let's see, so I'm just thinking out loud right now. So we want to find the height of the new water level. Well, let's start with just finding the volume of the water. Okay, so we've got it half full, which means our measurements are going to be 50 by 40 by 20, right, to start off with, because 20 is half of 40. So here's where the original water level was before we put those cubes in there. And we'll go ahead and do that multiplication, and we're going to end up with 40,000 centimeters cubed. Okay, now we already talked through the volume of the cubes, the small cubes, but let's go ahead and just write that down and figure out that multiplication. 10 times 10 times 10, each cube is 1,000 centimeters cubed. I have 3 of them, so that means that I have 3,000 centimeters cubed in the little metal guys that are in there. Okay, so now that I know the total volume of stuff in the tank, I can find the new height. So I'm going to add those together, 40,000 plus 3,000, and I get 43,000 centimeters cubed. That's the total volume of stuff in the tank right now. Now we want to find the height of the new water level. So let's go ahead and plug in our numbers. Remember that our volume is 43,000 centimeters cubed, and I'm going to do all of this work with centimeters cubed because I can't find a centimeters measurement from a liters measurement. I need to keep these in centimeters cubed so my units are consistent. Okay, so I've got a length of 50 centimeters, a width of 40 centimeters, and I don't know the new height. So let's go ahead and find it by dividing both sides by 50 times 40. Okay, we'll cross these off. Cross off a 0 here, cross off a 0 here, and I'm left with 430 divided by 20. I multiplied that 5 times the 4 equals height. Oh, I can cross off another 0 here, and I have 43 divided by 2. And so my height is going to be 21.5 centimeters. And that's my answer. Okay. We're going to take a little break here. I'm going to show you a slide with perfect cubes, and you're going to copy them into your notes. I want you to copy these, and I want you to memorize them. Knowing these cubes is going to make your life so much easier, because you'll be able to look at, a problem like we just had with those little metal cubes, and you'll know if they have an edge of 10, you're just going to be able to do that math in your mind and get 1,000 centimeters cubed for the volume. So the more you have these memorized, the easier this unit will be for you. All right, so go ahead and do that right now. And then just work on, maybe make yourself some flashcards, just work on knowing these over the next few weeks. So you have some problems in your notes at the back there. Those are all Toyos. I encourage you to go ahead and do those, and then come back, and if you have been absent, come back and check your work with me tomorrow. Make sure that you are fully understanding how to do these problems, but they are exactly like the ones that I just demonstrated. All right, that's it for today. I hope you have a great afternoon.